All right, let's start our review of Unit 11, Radicals. What we've been doing is the tower method. Not the only way to do these, but that's the way I'm going to teach the review. So what I've been saying is, okay, an upside down tower, we always want to divide by 2 first. We check the first prime number. 240 divided by 2 is 120. Then we're going to check that by 2. And we get 60. And then we're going to divide that by 2. And we get 30. That's divisible by 2. 15. Then we divide that by 2. Oh wait, doesn't work. 2 doesn't work, we try 3. And it does work, and it gives you 5. You keep doing this until you hit a prime number. Okay, so since we are now done with our prime factorization, that's what that's called, what we do, there's an index, remember, an index of 2 right here. Okay, I'm sorry about that. There's an index of 2 right here. If you don't see it, there's a 2. So that means you look for pairs. So we're going to circle and we're going to cross off whenever we see a pair. I actually have 2 pairs here. So we're going to circle and cross off. Lots of 2's here. It must be Tuesday. So we're going to circle and cross off, circle and cross off. We can't circle anything here because there's no pairs. So if you remember here, the circled numbers come out front. That was the routine we've been going with. And then the untouched numbers go inside. The crossed off numbers are gone forever. So untouched here would be 3 and 5. So we take the product of those two, which is 15. Okay, so 4 root 15 is the answer to this one. Next one. Now we're going to introduce some variables. And remember, the index is 2 on this one, so I'm going to put a little 2 right there. But if we were to tower the 50, what we first do is obviously check 2, which works, and we get to 25. And then we're going to try 2, doesn't work. 3 doesn't work, but then we see that obviously 5 gives us 5. And then we're going to circle, and we're going to cross off the pair of 5s. So 5 goes out, 2 goes in. So we have 5 root 2. But here's the deal. I want to be able to have a little gap here because we're going to do stuff with the variables as well. So switching colors to blue here for the variables, you look at this number. Remember the routine here. How many times does 2 go into this power of 3? 2 goes into that power 1 time. So that's how many x's we take out, 1x. Well, it didn't go in evenly. There was 1 left over. Like we put in a 2, we're 1 gap away from 3. So we have to put 1x back inside. 2 goes into the power of 6 3 times, so that's the exponent on the y's here that we take out. And it went in evenly, so there's nothing left inside. So actually 5x y to the third root 2x is the answer to that problem. All right, moving down, same kind of concept here. We're going to take 48, and I'm going to tower it. The tower stays the same no matter what the index. So as I tower this, I'm going to explain to you that the index on this problem is actually 3. So when we're done towering here, we're going to actually look for not pairs this time, but for triples. So looking here, I've actually got a 2, and now I'm going to cross 2 off. I make 3 markings here. I circle and I cross. I have no more triples, so I can't take anything else out. So I take the 2 out. I know there's going to be a cube, a cube root, and then we're going to have a 2 times 3 or a 6 inside. Okay, and then we'll switch to the variables here. How many times does 3 go into 4? Once, you say, so we put an x out. It's 1 away from 4, so we actually put an x in. How many times does 3 go into 12? 4 times. So we're going to take out 4y, so y to the 4th. 3 does not go in. There's a little power of 1 on that z. 3 is bigger than 1. It doesn't go in there. And if that happens, then you just put the z right back inside. So there's our answer to this one. Okay, towering 80 over here. 80 divided by 2. Looks like we might have a bunch of 2's coming out here. 2. 20, no, I won't make the 2 joke again. 2 divided by 2 gives us 5. So 2, 2, 2, 2, 5. Now the index here is 4. So since the index is 4, we're going to circle, cross, cross, cross. So by doing that, we've gotten rid of 3 2's. 1 2 comes out. Okay. then we're going to have that fourth root that goes back inside of 5. All right, so then we have, how many times does 4 go into 6? Still one time there. But 4 going into 6 one time leaves a gap of 2, so we have to have x squared inside. 4 goes into 4 one time, so we are going to take out a y, and there's nothing left to put inside because it went in evenly. And then 4 is bigger than 3, so that means that we don't do anything with the z's. Okay, I am feeling this with the radicals. All right, moving along here. We're going to keep going with this radical concept. Hold on a second. Okay, there we are. Now the next learning target is adding and subtracting radicals. Okay, the only way you can add or subtract radicals is if they are the exact same. If they're like radicals. We treat them like combining like terms. So first of all, this one has no radicals that we can simplify. I'm just trying to get you to understand that those are like radicals. So 3 root 10 plus 9 root 10 is simply 3 plus 9, which is 12 root 10. And then this one here is root 3, obviously. And we have, a negative 2 root 3, positive 2 root 3, and I really don't have anything. They're going to cancel off here. So I just have 12 root 10. Now looking at number 2, you could say, oh, they're not like radicals, we're done. Unfortunately, it's not that simple. So this one actually, if you simplify it using your tower, divided by 3 is 15, and then divided by 3 is 5. It's an index of 2, so we look for a pair, and we're going to have 3 root 5. Now here's the kicker. As I write plus 3 root 20, I'm making this red right now. A lot of us were struggling with the 3 out front here. So 3 times, and then we actually want to simplify root 20. But don't forget that there's a 3 times out front. Okay, so simplifying the root 20 using my tower, 20 divided by 2 is 10, divided by 2 is 5. So I circle cross 2 root 5. So I have 2 root 5. But I have to do that radical there, or I'm sorry, that multiplication there. So this becomes 3 times the square root of 5 plus 3 times 2, 6 root 5. Now I can finally do this addition because the radicals are the same. 3 plus 6 is 9 times the square root of 5. Okay, moving down into learning target 11C, multiplying radicals now. Okay, so what we want to do is, the tricks I said to you were outside with outside, inside with inside. So obviously 2 times 6, those are both outside numbers, so that's going to be a 12. 2 times 6 is 12. And then the inside numbers are 3 and 40. Okay, so 3 times 40 is actually 120. So that's one way to do it. You could simplify the root 40 first and then try to do it that way. There's multiple ways to do this, but I'm just going to say outside with outside, inside with inside. But now we can't be done because this looks like a large number that I might be able to simplify. So I'm going to look to the 120 tower and see what happens. So if I take 120, divide by 2, 60, divide by 2, 30, divide by 2, 15, and then by 3 I get 5. Okay, so I'm going to circle and cross. Nothing else. So here's the deal. I've got that 12 out front. Please don't forget that that 12 is still there. I'm going to multiply by, well, I got to simplify root 120. So that's a 2 out. And then when we take 5 times 3 times 2, that's actually 30. So we have a 30 inside. So this becomes 12 times 2 on the outside, or just 24 times the square root of 30. And that would be our final answer right there. Okay, now I know you know the distributive properties, so we are going to bring that through. And as we're doing so, you need to be thinking outside with outside, in with in. Well, that's really a 1 root 5. So 1 times 2 on the first distribution is just 2. Root 5 times root 3, they're both inside numbers, so that's a root 15. And then root 5 times root 4. All right, so when we do this, we got to realize that that's actually going to be the square root of 20. And then 2 root 15, nothing I can do there. That 15 cannot be broken down, but this root 20 can be. We did that just a little bit earlier, and it actually broke up, if you tower it, if you simplify it, to 2 root 5. Okay? Now, if I look here, these are not like radicals, so there's nowhere else I can go with that. Now, of course, I always like to tell you the different ways to do these. If you look right here, root 4, that actually is just the number 2, if you would have seen that at the beginning. So it would have been root 5 times 2, and you would have gotten 2 root 5 right away. Okay, but no worries if you didn't see that. Now, this one here, hopefully you're seeing, this is going to be a FOIL problem. Okay, and there's not going to be much we can do with this problem the way it's kind of set up, but we can FOIL. The first here would be outside with inside, so that's just going to be 2 times the square root of 6. And then outside is going to be 2, which is an outside number, times the root 3, which is an inside number, but there is a negative here, so very careful. So it's going to be a negative 2 times the square root of 3. And then the inside terms here, it's kind of hard saying inside for FOIL and inside for the radicals, but the inside for the FOIL has 2 inside numbers there, root 5, root 6. One of them's negative, the negative root 5, so this is going to be a negative root 30, and we can't break that down. Remember when we had 30 up here, we tried to go 2, 15, 3, 5, nothing paired up, so you can't break that down. Okay, and then the last here is the root 5 times the root 3, but they're both negative, so that's going to be a positive square root of 15. All right, so since there's nowhere to go there, that's going to be our final answer. There's no like radicals, nothing can be broken down, and we're good. Okay, now be very careful. Your urge on this next one might be to distribute that 2 through, like going like this. We do not do that over addition. That is not something we do. So instead of doing that, you want to always rewrite these problems as if they said 2 plus root 3 times 2 plus root 3. Any number squared is just that number times itself. So then we FOIL, just like before. So 2 times 2 is actually going to give me a 4. Outside, if I were to do the outside, I would get 2 times root 3. The inside's giving me the exact same thing, plus 2 times root 3. And then the last here is root 3 times root 3, which we know is just the number 3. So combining like terms of the 4 and the 3 here, I'm going to get a 7. And then combining like radicals here, 2 root 3 and 2 root 3, it gives me a 4 root 3. So 7 plus 4 root 3 is what we ended up getting there. Okay? All right, moving along, learn check at 11D. Gave you a couple here, not too crazy. I just wanted to reteach you that we can't have a radical on the bottom. So what we do in that first case is we multiply the top and the bottom by that radical. And that's going to be just 4 root 3, nothing much you can do on top. And on the bottom, that just becomes a 3 there. You cannot simplify inside with outside, so that's good. All right, this one, you can't multiply by root 2 over root 2 if you remember that. We explained that many times why you can't. But we're going to multiply the top and the bottom by 1 plus root 2. And if you remember that term, do you remember that term? What is that term? Think of it in your head. You can do this. Good job. That's a conjugate, okay? The conjugate. So on the top there, the 5 is going to distribute through, and we're going to have 5 plus the square root, whoops, sorry, let me back it up, going too fast. 5 times 1 is 5, and then 5 times root 2 is going to be 5 root 2. And then on the bottom, I'll work through the FOIL in red here. The first gives me 1 times 1, which is 1. The outside gives me a positive root 2. The inside, a negative root 2. And then the last, positive times a negative is a negative, just the number 2. And then these outside and inner terms cancel off. That's why we picked the conjugate, to get them to cancel off. So now I have 1 minus 2, and that's actually negative 1 on the bottom. And there's nothing more we can do on that problem. Okay? All right. I believe we are working towards our last learning target here, if I can find it. There it is. And you guys kind of like this one. This, the whole procedure here, if you remember, is to step 1, get the radical alone. Step 2, square both sides. Step 3, solve. But we want to make sure we check our answers in case they don't work out, because sometimes they don't work out through the squaring procedure. All right, 2 plus 6, do not do 2 plus 6, okay? Order of operations, PEMDAS says you cannot do this addition before we do multiplication. So when we're solving, we can't do it either. So minus 2 to both sides, that's got to be the first step. So now we have 6 times the square root of x plus 2, and that equals 18. And then we're going to actually divide by 6, not subtract, but get rid of this multiplication with division. So this is going to become the square root of x plus 2 equal to the number 3. And now we're at that phase where, radical's isolated, so we're going to square both sides. Anything, the radical squared is that times itself, so we're just going to get the x plus 2 out. On the right side, 3 squared is going to give us 9, and then we get x equals 7 when we subtract 2 from both sides. Now here's the deal, that's a possible answer. What we got to do here, and I'll switch to blue, is we got to check our answer. If we do this, we would have 2 plus 6 times the square root of 7 plus 2. And that's supposed to come out to 20. We'll see if it does. That's 2 plus 6 times, well, if you look in the inside here, that's really the square root of 9. Square root of 9 is 3. Is that equaling 20? Well, we got to do the multiplication first, so that would be 2 plus 18. It is equaling 20. It checks out. This is our answer right here. X equals 7. Okay, look at this one here. We have a multiplication, so what we want to do is we want to divide by 3. Well, when I divide by 3 here, the 3's cancel, and I get the square root of 2x plus 1, and that equals -1. Okay? Now, I have isolated the radicals, so I'm going to do this. Okay, and on the right side, -1 squared, or -1 times -1 is 1. Subtract 1 from both sides. I have 2x equals 0. And remember, just think about this logically. Don't try to do math here. 2 times something equals 0. Well, we know that that number would have to be 0. So what we do is we say that's our answer. We put a smiley face down. We do a victory lap around the track. Is that what we do? No, we undo that victory lap and we say, wait a minute, let's go check, because that's the way we've been taught. So what we would have, original problem, 3 times the square root of 2 times my answer of 0 plus 1. And we're trying to see if that's going to come out to -3. Well, that's 3 times the square root of, 2 times 0 is 0, plus 1 is 1, the square root of 1, right, equals negative. This is not happening because the square root of 1 is 1. 3 times 1 is actually equal to -3. This does not check out. No. So since this was our only possible answer and it didn't check out, that would be no solution. Now, if you're scoring at home, hopefully you're understanding. I hope you saw this, a lot of you, is that, right up here we had a problem where we had 3 times the square root equal to a negative. I hope you know that a square root can never be a negative here, so not in the real number system. So what we have here is right off the bat, no solution. Like, you could have seen that at the beginning. Just be very careful. Some problems, and I know I'm over teaching here, sorry, but some problems might say this, like 2 plus the square root of x equals -1. Well, just be very careful. If this was like a -2 plus, we would actually end up adding 2, and then you would have a positive on the right side. So just be careful. If you have the radical alone and the right side is negative, then it's going to be no solution. Okay, I hope this gives you here on the entire unit, but hopefully these helped. Thank you for your time.